Hello good day viewers, welcome back once again. Please kindly subscribe to my channel, also like, comment and share. Today we have this Putnam math challenge, right? And this happens to be a definite integral. Here we're given that I is equal to the integral from 0 to 1 of the natural log of 1 plus x all over 1 plus x squared dx. Mind you, this is a Putnam math problem, right? Now in this video, I'll be presenting only one solution. But mind you, there are different methods through which this integral can be evaluated. Now let's go straight to the video. Okay. Now in this problem, I'm going to start by making a very nice substitution. So I'm going to let x equals the tangent of theta. So let me use the variable theta, right? We all know that here theta is equal to the arctangent of x, right? But right from here, we can differentiate both sides. So we get dx is equal to, sec squared theta d theta, right? So our I now is going to be equal to the integral. Now let's talk about the boundaries of integration, right? Now recall that theta is equal to the arctangent of x. Now when x is equal to 0, theta is equal to the arctangent of 0, which is 0. When x is equal to 1, theta is equal to the arctangent of 1, which is pi all over 4, right? Okay, so here we have the natural log of 1 plus the tangent of theta. Then right over here, this is all over 1 plus, x squared will be the tangent squared theta, right? And here, dx is sec squared theta d theta, right? Okay. Now here we have I is equal to the integral from 0 to pi all over 4. The natural log of 1 plus the tangent theta all over, we all know this property. So that is a trigonometric identity that 1 plus the tangent square theta is equal to the secant square theta, right? Sorry, theta I mean. Then here, times secant square theta and here d theta, right? So from here, secant square theta and secant square theta we cancel out. And from here we have this is equal to the integral from 0 to pi all over 4. The natural log of 1 plus the tangent theta d theta, right? Awesome. Now from here, we're going to make use of a very well-known trigonometric identity or ratio. We know that the tangent theta is equal to the ratio of the sine theta and the cosine theta, right? So here, our I is equal to the integral from 0 to pi all over 4. Then here the natural log of 1 plus, here we have sine theta all over the cosine theta, right? Then d theta. So here this is equal to integral from 0 to pi all over 4. The natural log of, the common denominator here is cosine theta, right? And right over here, we have cosine theta, then plus sine theta, right? And here, d theta. So we're going to make use of a very well-known logarithmic property, right? And what's this property? When we have the natural log of a over b, this is equal to the natural log of a minus the natural log of b, right? So from here, I is equal to the integral from 0 to pi all over 4. The natural log of cosine theta plus sine theta, right? Then minus the natural log of the cosine theta. Then here d theta. And here we split as follows. the integral from 0 to pi all over 4, the natural log of the cosine theta plus the sine theta d theta, then minus the integral from 0 to pi all over 4, the natural log of the cosine theta, right? And here d theta. Okay. Now, let us record this identity. The cosine theta plus the sine theta, this is equal to square root of 2 multiplied by the cosine of pi over 4 minus theta, right? So we're going to use this nice identity. In fact, the identity is awesome, right? Okay. So from here, I is equal to the integral from 0 to pi all over 4. Here we're going to have the natural log of square root of 2 multiplied by the cosine of pi over 4 minus theta, right? Then d theta. And here we have minus the integral from 0 to pi all over 4, the natural log of the cosine theta, d theta. Okay, from here we're going to make a substitution. We're going to let pi over 4 minus theta equals x, right? And here we have theta is equal to pi over 4 minus x. Differentiating both sides, we get theta is equal to negative dx. Okay. So from here we have I is equal to, this integral? The integral now. When theta is equal to 0, x is equal to pi over 4 minus 0, which is pi all over 4. And up there, I believe the upper limit will be 1. And from here, we have the natural log of square root of 2 cosine of, this is equal to x, right? Then d theta here is negative dx. So multiply by negative dx, right? And here minus the integral from 0 to pi all over 4, the natural log of, this theta also serves as dummy variable. So we can change it to x, right? So we have the natural log of cosine of x and here dx. Okay. Now with this negative sign, the limits will switch, right? And again, we need to know that the natural log of a times b is equal to the natural log of a plus the natural log of b. So we're going to make use of this property right over here because we have the product of square root of 2 and the cosine of x, right? So here we have I is equal to, with the limit switching from 0 to pi all over 4, the natural log of the square root of 2, right? Then we can put the x, then plus the integral from 0 to pi all over 4, the natural log of the cosine of x dx, and here minus the integral from 0 to pi over 4, the natural log of the cosine of x dx. So we can see that from here, the whole of this equals 0, right? So from here we have I is equal to the natural log of the square root of 2, then the integral from 0 to pi over 4 of dx, and from here this is equal to the natural log of square root of 2, then multiply by, the integral of a constant with respect to x is x, then limit from 0 to pi over 4, and from here this is equal to the natural log of square root of 2 multiplied by pi all over 4. But we can simplify this further. So having it known that the natural log of square root of 2 is the same as the natural log of 2 raised to power 1 over 2 multiplied by the pi all over 4. This power here we cross over to multiply the entire logarithm, right? So here we have I is equal to 1 over 2, the natural log of 2 multiplied by pi over 4, and properly simplifying this, we get pi times the natural log of 2 all over 8. And this is the right answer. Thank you for watching. Please, if you enjoyed this video, kindly subscribe to my channel. Also like, comment, and share. Bye-bye.